In this video, I'll be walking you through the post lab for Lab 7, colligative properties and the Van't Hoff factor. On your post lab, you have 3 sets of data, trial 1, trial 2, and trial 3. You repeated the experiment 3 times. These 3 sets of data should be pretty similar to each other. They are not going to be exactly the same, or they probably won't be exactly the same, but they should be pretty similar. In the lab, you began by recording and reporting the mass of NaCl that you used for each one of these trials. In the next spot on this data table, you're going to be converting that mass from grams into moles using the molecular weight of NaCl, which is, if I remember correctly, is about 58 grams per mole, but you should look it up because I don't always remember that correctly. So this is going to be just a simple gram to mole conversion for each one of these trials. In the experiment, you used 100 milliliters of water, and you used that for every one of the trials, so I have that already filled in for you in that spot. You are going to convert that volume from milliliters into grams, and you're going to do that anytime you need to do a conversion between volume and mass. You do that using the density of that particular substance. So the density of water, which is approximately 1 gram per milliliter. Now, it's not exactly 1 gram. If you want to use 1 gram per milliliter in these boxes, that's fine, but you're going to get more accurate data if you look up the actual density of water at room temperature, which is about 25 degrees. It's a little bit less than 1 gram, like maybe it's 0.998 grams per milliliter, something like that. Either way, this is going to be a conversion. You're using the density equation. Density is mass over volume. So if you have the volume and you're trying to calculate mass, you're going to do that by multiplying the density times the volume. Then in our next box, we're going to take that mass of water and we're going to convert it into kilograms. So this is going to be a gram to kilogram conversion. And this is just with the water. We're not going to be including the mass of NaCl in this spot right here. Now you'll use that information to calculate the molality of the NaCl. The molality is the moles of NaCl, which you calculated right here in this spot, and you're going to divide that by the kilograms of water, which you just finished calculating. So your kilograms of water and your moles of NaCl. Now the normal freezing point of water is 0 degrees Celsius. I've already got that filled in for you. This is not something that you measured in the experiment. That's just something that we know. Here you will have reported the freezing point of your NaCl solution. So this is data that you collected in the experiment right there. And then down here in this spot, you're going to report the change to the freezing point of water. So this is going to be the difference between the normal freezing point of water, which is 0 degrees, and whatever you reported for your freezing point. I'm just going to write freezing point of the solution. And then notice that I'm putting these absolute value bars around it because this needs to be a positive number. So we're using the difference between the normal freezing point of water and the freezing point of your solution. We're turning it into an absolute value, so this is going to be a positive number. The freezing point depression constant, the Kf for water, is 1.86, so I have that written down for you. And what you're going to do is calculate the Van't Hoff factor for NaCl. That's going to be done using the equation for the freezing point depression. Delta Tf is I Kfm. The Van't Hoff factor is I in that equation, so that's what we're trying to solve for. And that's going to be solved by rearranging that freezing point depression calculation. So it's going to be the change in freezing point divided by the freezing point constant times the molality of the solution. Your change in freezing point you calculated right there. The Kf is provided to you, and the molality you calculated all the way up here. So you're going to be calculating the value of I, and you'll repeat that calculation 3 times. These these values down here, they should be pretty similar to each other. They might not be exactly the same, and that's why down here you're just going to calculate the average value of I. To do that, you're going to take the first value of I, I'm just going to call that A, you're going to add it to the second and add it to the third, and then you're going to divide that by 3, where I'm using the letter A to represent the first calculated I, B is the second calculated I value, and C is the third. Divide that by 3. And that's all you have to do for this.